Hello everyone, I'm Danula Hettiachchi from the University of Melbourne, presenting our work CrowdCog, a cognitive skill-based system for heterogeneous task assignment and recommendation in crowdsourcing. Let's start by looking at data quality in crowdsourcing, which is an important research question. Researchers have studied data quality issues from different dimensions, such as work attributes, platform and requesters, and data and post-processing techniques. In our work, we explore the promising direction of using cognitive skills of workers. In particular, we want to achieve task assignment or recommendation for heterogeneous tasks or different types of tasks. There is limited prior work on this space, while many methods and frameworks focus on question assignment. Our work is built on the concept of executive functions that describes human cognitive ability. We focus on three primary executive functions named inhibition control, cognitive flexibility, and working memory. We build on our prior work, which highlights the relationship between cognitive tests and crowdsourcing tasks. To match workers with crowdsourcing tasks based on cognitive test outcomes, and to test if task matching works in a real-world environment, we developed CrowdCog. It is an online system that works on top of standard crowdsourcing platforms. Here you can see an overview of the task flow in CrowdCog deployment. An important factor here is that our system aims to identify a suitable task for each worker using a minimum number of cognitive tests. Let's examine the flow, starting with a worker attempting a task that is connected to CrowdCog. Please note that we also use several parameters, such as number of cognitive tests to be included in each hit, and I'm not detailing all of these parameters right now. First, we start with a simple check to see if we still need answers for our tasks. Then, we assign new cognitive tests if available and predict the task performance for candidates using the test outcomes. In CrowdCog Assign, we directly assign a task based on the predictions, but in CrowdCog Recommend, we show the task list highlighting recommended tasks. Workers can still select the task they prefer. Based on the requester or platform preference, we can either use CrowdCog Assign or CrowdCog Recommend. We used 5 different cognitive tests relating to 3 executive functions and also 4 different crowdsourcing tasks that are commonly available in commercial crowdsourcing platforms. Our system was seamlessly integrated with Amazon Mechanical Turk platform, and we deployed our experiments under 5 different settings, where 574 workers completed nearly 1,000 hits in total. We compared our system with a baseline strategy that is comparable to typical assignment methods in current commercial crowdsourcing platforms, a state-of-art question assignment strategy, and also a standard history-based method where we filtered workers based on the number of tasks completed and the approval rate. In CrowdCog Recommend, we see that workers are more likely to work on a recommended task and also produce high-quality work when they do so. In CrowdCog Assign, one key observation is that 72% of the workers were assigned to at least one of the tasks when they completed all 5 cognitive tests. Then we compare our methods with other experimental conditions. From a Kostakos rank sum test, we report a significant difference in accuracy among 5 conditions. Also, from our post hoc tests, we show that the accuracies in both CrowdCog Assign and CrowdCog Recommend are significantly higher than the baseline accuracy. You can also see the accuracy difference between conditions across different tasks. In our paper, we discuss in detail how CrowdCog can be implemented in a crowdsourcing platform. We also discuss how we can repeat tests, how we can find the mapping between new tasks and the cognitive tests. We also look at why it is important to use task assignment as opposed to question assignment, and also why it is valuable to consider task recommendation. That's a brief overview of our paper, and I would like you all to read our paper for more details. We have also provided the source code for our system in supplementary material. I am a final year PhD candidate at the University of Melbourne and an applied scientist intern at Amazon Web Services. Feel free to contact me through my email address, and also you can get in touch via my website. Thank you.